This is 7.6, day 3 of solving quadratics by factoring. I want to make sure that you are listening to this video, not just watching it, but listening to it. And remember to pause the video as needed to fill in the notes, okay? So in the previous days, we've had day 1 and day 2 of this lesson. We have used GCF, the greatest common factor. We've also used the product sum method, and we've used the difference of two squares. Today we're going to look at these where we have either a GCF or we're going to be using the slide divide bottoms up. In this first example, you'll notice that we have a 3, a 9, and a 12. All of those are multiples of 3. So we have a greatest common factor of 3 that we're going to factor out. That means to divide out from each one of these terms. So dividing each of those terms by 3, we get x squared plus 3x minus 4. And the 3 is on the outside of the parentheses. And now we have this quadratic, and we're going to use the product sum method. So I'm thinking of what two numbers multiply to give me negative 4, but add to give me positive 3. Will now be negative 4 and positive 1. So that's the product sum factor. And so we're going to finish writing all of our factorization. We still have the 3 on the outside, and then we have these groups. And just like we've been doing so far this whole week, we set each of the factors equal to 0. So we would do this bar going across on a line between the two factors. And now the factors I'm looking at are in the groups, in the parentheses, x minus 4 and x plus 1. So I set each one of those equal to 0, and then I solve each one. I'm going to add 4 to both sides of that first factor and get x equals 4. And I'm going to subtract 1 from the other one. And I have two solutions, x equals 4 and x equals 1. Now, granted, there was another factor, 3, but 3 will never equal 0. 3 is just 3. So we only had the factors x minus 4 and x plus 1. All right, let's look at this next example. And once again, I'm going to follow these same steps. I'm going to look for the greatest common factor. Then I'm going to do the product sum factorization after I factor out the greatest common factor, set the factors equal to 0, and solve exactly what I did over here. So now I'm looking at these terms, and I'm noticing they all are multiples of 5. So I'm going to divide them all by 5, and I'm left with x squared minus 4x plus 12. Using the product sum method, what multiplies to give me negative 12, but adds to give me negative 4? Well, that would be positive 2 and negative 6. So I'm going to write my factorization. The 5 is still there, and then I have x and minus 6 and x plus 2. Now we set the factors equal to 0 and solve each one of those. I'm going to add 6 to both sides to solve that one, and I'm going to subtract 2 from both sides for the other one. And I have my two solutions. Okay. Pause the video as needed to write down all of this information in your notes. We're going to move on to the next couple problems. We've got example 3. Now I'm looking at this. Now, also, I forgot to mention, we've had this for several days now. It has to always equal 0 to do any of this factorization that we're doing. Now I'm looking at this one and saying, well, there's no greatest common factor. So what do? Well, when there's no greatest common factor and I still have a number in front of x squared, something other than 1, I'm going to use the slide divide bottoms up method. So the first part of this is to slide that number to the last term and multiply. So I'm going to get 2 times negative 5 for my last term. And we end up with x squared plus 3x minus 10. And then we do the product sum factorization. So we did the slide, and then after we slide, we factor. Now we're back to the same things we did before, where we would try to, we're not at the same thing before, because this is slide, divide, bottoms up. We did our slide, and then we factored. Now we have to do our divide by the slide. So we slid 2. And whenever we slide, we have to also divide that back out. So we're going to take these numbers, the positive 5 and the negative 2, and we're going to divide them both by 2 and simplify where we can. Now the 5 halves doesn't simplify, so we leave it as 5 halves. But the negative 2 divided by 2, well, that simplifies to negative 1. So doing that simplification, I have x plus 5 halves times x minus 1. And then we do the last part of our the step, because this was the slide, divide, bottoms up. I'm looking here and saying, oh, what's in the bottom? The only one that has a bottom is this 2. So that 2 is going to come up in front of the x. And when we finish that up, we have 2x plus 5 times x minus 1. Now this is the factorization of the original problem up here. We had to do all of this just to get to the factorization. Once we have now completely factored the polynomial, the quadratic, we do the bar and the line, and we set each of our factors equal to 0 and solve. Well, this first one, to solve for it, we're going to subtract 5 from both sides. So that's the first thing we're going to do by solving. We're going to subtract 5 and be left with 2x equals negative 5. Now we need to divide both sides by 2 and write the final answer for that, which is x equals negative 5 halves. That's our first solution. We're going to now go over to this side. We're going to add 1 to both sides, and we get our second solution. So we have 2 solutions for example 3. Now example 4 is the same idea. We're going to do the slide, divide, bottoms up, because there's no GCF. We always, always, always start with, is there a GCF? And no, there's no GCF. Since there's no GCF, we go straight to slide, and then we're going to do the product sum factorization. Then we're going to divide by the slide and simplify, bottoms up, and it will now be factored. Once it's factored, once we get to this step, it'll be factored, and we set the factors equal to 0 and solve. So this is your rule of what we're going to do. So sliding 8. 8 times 5 is 40, so we end up with this quadratic. Now we do the factorization of this quadratic with the product sum. What multiplies to give us 40, but adds to give 22? Well, that would be 20 and 2. So we have the factorization. Now, this is the factorization of this problem that we slid. So after we've done this factorization of the slide, we divide by the slide. We slid 8, so we're going to divide both the 20 and the 2 by 8. And simplify. 20 divided by 2. This simplifies because they're both divisible by 4. And so we're going to end up with x plus, and then 20 divided by 4 is 5. And then we have 8 divided by 4, which is 2. So that was the simplification of 20 over 8, this fraction. Now we have to simplify the other fraction, and we get 1/4, because 2/8 reduces to 1/4. They're both divisible by 2. Now we're still in this purple part here where we divided by the slide, and we simplified. Now we're going to do the bottoms up. And I noticed that in this first group here, I've got a 2 in the bottom, so I'm going to bring that up in front of the x. And in the other group here, I have a 4 that I'm going to bring up in front of that x. So we have 2x plus 5 times 4x plus 1. Now we get to say we have factored. That was the whole point. All of this was to factor. Now we're going to solve. Since we've gotten all the way to factorization, we break this up and we set each of the factors, 2x plus 5 and the 4x plus 1, equal to 0, and solve each one of those. So we're going to subtract 5 and then divide by 2. And over on this other one, we're going to subtract 1 and then divide by 4. And we have our 2 solutions. So the first 2 examples were there was a GCF, and then we could just use the product sum factorization. With these 2 examples, example 3 and example 4, there was no GCF, so we had to go to the slide, divide, bottoms up method of factoring. We get it finally factored, and now we solve by setting the factors equal to 0 and solving. So you've got a bunch of problems to do, and I'm going to just tell you right now, again, this is the methods that we do. If there's a GCF, and I'm looking at this 2, 10, and 8, they all have a GCF. So we're going to do that, and then it's the product sum factorization, setting the factors equal to 0 and solve. Okay? In problem number 2, we also have a GCF, 4, negative 24, negative 28. All of those numbers are divisible by 4. So I'm going to use the GCF, and then I'm going to go straight to product sum method and all that. I'm not doing them, I'm just helping you start them off. But now looking at problem number 3. In problem number 3, there's a 3, there's a 13, and a 10. There's no GCF. So that means we're going to be doing the slide, divide, and bottoms up method for problem number 3. And in problem number 4, once again, I'm looking at those numbers, 5, negative 8, and 3. Again, there's no this was the beginning of problem number 3. I'm not going to do the whole thing, but I did show the slide. In problem number 4, there's no GCF, so we're going to do the slide, divide, bottoms up, where you would slide the 5, and when you slide the 5, you get this quadratic, and then you're going to do all the steps that it shows here to get to the factorization, and then set the factors equal to 0 and solve. You need to do numbers 1 through 12 all the way. So I gave you the start for problems 1 through 4. But you need to finish all the rest of them, meaning there's 12 problems to do. And you need to have them done before the end of the period and turn them in. Don't take them home. Whatever you finish, turn them in to the sub. Okay? You should also have, for some of you, you did not finish the previous day's work. You need to turn that in as well. So you've got all of those problems to do.